We've already talked about quadrilaterals in the last video, but let's take it a little more in depth and look at it algebraically. So a quadrilateral, we already know, is a polygon with 4 sides and 4 angles. If you look to the quadrilateral on the left, if I identified the sides of this polygon, I could say that they are ZW. Notice capital letters followed by the segment because there's a clear beginning, clear end. And then I can do WX, capital letter. I can do YX, capital letter, and I can do ZY, all capital letters with a segment. Doesn't matter the ordering, so don't get caught up in that. The angles are angle W. Notice the angle measurement, uppercase W, angle Z, angle Y, and angle X. We know that the sum of the measures of a quadrilateral, we already talked about it, that the sum of the interior angles is 360 degrees. Therefore, I can make an equation, and I can say that angle W plus angle Z plus angle Y plus angle X all equals 360 degrees. I add them all up, they equal 360, which is exactly what I'm going to do here. I can say 95 plus 72 plus 137 plus X all equals 360 degrees. When I combine all my like terms, I get X plus 304 equals 360. Subtract 304 on both sides, and I get X equals 56 degrees. Okay, so numbers 1 through 4 are pretty simple in that you just add them all up, set them equal to 360, and solve. You guys are experts in solving for equations, so I'm not worried about that coming from you guys. Let's jump down and look at number 7. So 7 and 8, you just kind of piece them together as you go. So you got to do 2 things here. Here we're dealing with a triangle. How many degrees are in a triangle? 180. So I can say that 97 plus 58 plus angle 3 is all equal to 180 degrees. So when I combine these, I get 155 plus angle 3 equals 180. And when I subtract 155 on both sides, I get that angle 3 is equal to 25 degrees. So angle 3 is 25 degrees. Now that I have angle 3 identified, I can go back and look at 1 and 2. I know that 97 and angle 2, what kind of angles are these? Vertical. That vocabulary that we learned at the beginning is going to come all the way through this unit and so on when you get to geometry in the upper school. So hold on to these terms. So if this is 97, angle 2 is 97, that's because of vertical angles. Now I can just use the sum of interior angles, add them all up. 61 plus 97, that's 90 degrees, it's a right angle, plus X, or angle 1, all equals 360 degrees. So when you combine all your like terms, I get 248 plus X equals 360 degrees. Subtract 248 on both sides, and X equals, I think, 112. Bam. So you just simply piece all the stuff together and then solve your angles. These are fun. They're like a puzzle piece. You just got to figure them all out. So that's how you would solve algebraically. If you flip over to the next page, so on this one, it's the same thing, except now we just have variables and constant terms. You're still going to add them all up. 6x minus 5 plus 5x plus 2 plus 11x minus 9 plus 8x minus 18 all equals 360 degrees. Whew, that's a mouthful. So when you combine your like terms, 6, 5x, 11x, 8x, this is 11 and 11, 22, 22 and 8 is 30x. And now you get negative 5, positive 2, negative 9, and negative 18. So that's negative 4, and 2 is negative 2, and negative 18 is negative 20. So then you add 20 to both sides. 30 equals 380. And then when you divide both sides by 30, I think my math is right here. 30x, oh, this is minus 30. I'm sorry, guys. That's negative 3. Negative 3, negative 9 is negative 12. This is negative 30. Negative 30. So we're going to add 30. Sorry about that. So that's 390. Sorry for the confusion. And then when you divide by 30, I get x equals 1, 3. X equals 13. Now, here's the deal. I need x in order to solve the angle measurements. But in order to answer the question, you have to go back and plug in x for each value. So if you look at k, I'm going to do 6 times 13 minus 5. And 6 times 13 minus 5 is going to give us 73 degrees. Okay, so if you go over to L and you plug in 8 times 13 minus 18, so 8 times 13 minus 18 gives me angle L, which is 86 degrees. So to solve for angle M, 11 times 13 minus 9. And when you do 11 times 13 minus 9, we get the value of 134 degrees. And then you do it again. 5 times 13 plus 2 to give me angle J, and that would give me 67 degrees. You always check your work because you get the sum. All of these is going to equal 360 every single time. So that's how you would look at it with algebra. Now let's go through and classify these. So on the last video, we kind of looked at them and we classified them. Parallelogram, we're just going to place a check mark. Exactly one pair of opposite sides? Nope. Both pairs of opposite sides are parallel. Opposite sides are congruent. 4 congruent sides? Nope. And 4 right angles? Nope. So only 2 truths in the parallelogram are that their opposite sides are parallel and opposite sides are congruent. Rhombus, that's not it, fits the parallelogram and it has 4 congruent sides. Okay? Does not have 4 right angles. A rectangle fits the parallelogram. It doesn't have congruent sides, but it does have 4 right angles. A square doesn't have exactly 1 pair of sides, fits the parallelogram, fits the rhombus, and fits the rectangle. All check marks. And then the trapezoid is the only one with 1 pair of opposite sides. Nothing else is true. So hopefully you can mark those in based on our previous video that we did together. If you just want to have fun in classifying the quadrilaterals, and I look down here, I'll just go down these right here. Number 10 is a square. Because all sides are equal, all angles are 90. Number 12, it's not a parallelogram, it's not a trapezoid, so what's the only thing that we know about it? It's quadrilateral, 4 sides, that's it. Done. Number 14, both sides are parallel, opposite sides are parallel, so I know that it is a parallelogram. Rectangle on this one, rhombus on this one, trapezoid on this one. Number 16 is an isosceles trapezoid. And then number 17 is a quadrilateral. It still has 4 sides. Even though it's a funny looking quadrilateral, it still has 4 sides. And then of course, always, sometimes, or never, a trapezoid is never a rectangle. A rhombus is always a parallelogram. A square is always a rhombus. And a parallelogram is sometimes a rectangle. So that's just to kind of check, test your knowledge. I'm sure you wrote them down, though. Come see me if you're struggling.